we're going to go through this file and try to understand exactly how data is structured inside of Grasshopper so that we can kind of weave it together and pull it apart whenever we need to make sure that our definitions are working as they should. Whenever you have an issue in Grasshopper, things just aren't working the way that you should, you're getting big red errors, 90% of the time it's going to be because of a data structuring issue. It's kind of like the shape that your data is taking doesn't fit into the hole that you're trying to plug it into. So there's some stuff on the left-hand side that we're going to kind of ignore. We already kind of covered this basic input stuff. Number sliders, your bread and butter. There's a few other things illustrated here that might be interesting for you, just different ways of generating numbers or values. Most of these I never use. I've never once in my 10 years of using this software have ever used this little dial slider thing, but maybe that's really rocking your boat. Anyway, there's a bunch of different inputs here that you can explore on your own. The only other ones to really kind of keep an eye on are this Boolean toggle, which we touched on a little bit last class, I think, or maybe that was a different class. Anyway, this kind of true-false option here is kind of an interesting switch that we'll come back to later in time. So anyways, the gist of that is TLDR, we're just going to kind of skip these first two columns. And we're going to move on to this third one here, working with lists. We'll start from the top and we'll move our way down. I told you this was boring. We're going to work with lists for a while. But we're really just going to kind of break down and take a look at what exactly is happening with each list of information inside of Grasshopper. If you take a shot every time I say list this class, you will be passed out in 10 minutes. So please do try to pay attention, but I understand it's really hard. So anytime we have a list inside of Grasshopper, this is just a panel that's holding a bunch of information. It's kind of structured in a certain way to tell you about the information in that list. So over on the left-hand side here, there's a column of numbers that start at 0 and move their way up to however many kind of numbers or values are in that list. So these are called the index number. This number on the left-hand side in this column here, whenever it's asking for an index, it's asking what is its position in the list. So where in the list does it fall? This number describes, okay, what position does it have in the list? And that may seem stupid, but it's actually really helpful for helping you identify or grab out certain pieces of information. So the item or value at that specific point is going to show up to the right of your index. So all of the numbers or values that we're working with will be on the right-hand side. And then there's also this weird little number up at the top here, and this is called our branch number. Grasshopper uses a lot of tree metaphors for talking about data. So this number in the upper right-hand corner is talking more broadly about what branch or stream of information we're working in at a higher level. So we've got index number on the left-hand side, talking about its position, the item or value in the middle, and then the branch number in the upper right-hand side. And we've got a component here. This is a super useful component that you're probably going to use a fair bit inside of Grasshopper. This one's called list item. And this component helps you pull or grab out pieces of information from a list. You can see if I zoom in on it, it's got a couple of inputs on the left-hand side. It's got list up at the top. So what's the list of information you're trying to pull something out of? And we've got this big panel plugged into it here. Then we've got our index. So again, it's asking for this number in the left-hand column. So it's asking for a number on this left-hand side here. That's our index number. It's basically asking, okay, what's its position in the list? What's its number in the list? And then I'll grab it for you. So in this case, I've got a number slider plugged into index here. So you can see what's coming out of the other side is the number 8. So when this number slider is set to 4, it's spitting out the number 8 on the right-hand side. And you can see if we go back to look at my list of information, that's because it's grabbing this number 4 item in the list. So we told it, okay, we're going to give it an index number of 4. It's going to grab the item that's at position 4 in our list, and that happens to be the number 8. So we plug in 4, we get 8 out the other side. And if we change that number, so maybe I move the number slider around, maybe I'll change it up to the number 9. You can see that what it's then spitting out is the number 10. And that's because it asked for the 9th position in the list, which is going to give you this number 10 here. So the value is what it's splitting out. The position in the list is what we plugged into it. And that's how those two are kind of related. This might seem like a stupid thing to do with your time, but I promise you it's really helpful for kind of grabbing out specific pieces of information. That's what list item does. If I scroll down a little bit, you can see that same component lets you grab multiple things in a list. So we've got our list of numbers up at the top here that's being plugged into list on list item. And this time when it's asking for an index, so when it's asking, okay, which items in the list do you care about or want to grab? Now we've plugged in a couple different values. So we've got 2, 4, 6, and 1. And you can see what it's doing. It's spitting out the values at those positions. So 2, we can come up to index number 2, and you can see that the value is the number 2. So that's what we're getting at the top on the right-hand side. Next up, it's asking for the 4th position. So we go to index number 4. That number is 8, and that's going to be our second number that's it's spitting out. 6, so the 6th position, that value is 3. And then 1, so the first position, and that number is 5. Beep boop. Every list in Grasshopper starts with 0. This is kind of like a little tricky thing to keep in mind. So when you see that the last number in the list here is the number 9, so the index number is 9, that actually means that there's 10 values in the list because we do have to count this kind of first like 0 input here. So that's just like a tricky little stupid thing to keep your eye on. But that's the gist of what's happening. We can feed it index numbers on the left and spit out values on the right. There's one example here of just some little kind of like cheat codes to grab either the first or the last item in the list, no matter how long the list is. So in this case, you can see list item, again, we've plugged in index 0. So the index number 0, that's always talking about the very first item in the list. So it's always going to give you numero uno, this little value here. Just below that, this is a little cheat or hack to grab the last item in any list, no matter how long it is. So if we plug in a -1, -1 is kind of like a shortcut or a code for last item in the list. So instead of starting with 0 and then moving to 1, you're saying, actually, I want -1. And that's going to send it all the way to the bottom of the list and spit out that value here, which in this case is 10. So you can see that the last item that we're getting when we plug in -1 is this number 9 on our list, which has a value of 10. Does that make sense? It's so boring. I'm falling asleep as I'm telling this to you. I'm so sorry. We have to go through this. Okay, so that is list item. Another thing that's super helpful in Grasshopper is a different component called list length. All of this stuff is under the sets tab. This is a horrifying tab. I hope you never have to come in here, but it's basically just like all of this boring stuff that we're going to go through, talking about how your data is structured. So it's like data about your data. And the list length component, so we went through list item, now we're talking about list length. This is just a really straightforward component that counts all of the objects in your list. So it goes, okay, your list has 0, 1, 2, 3, 4, 5, etc., all the way up to 9. And it tells you how long that list is. So in this case, it gives you the number 10. Again, just something to keep in mind. You might think, okay, it has nine values. The index number stops at 9. It's probably going to tell me 9. Never forget that first secret little 0. It's like a silent letter in every word. So if this number seems off by 1 to you, it's because it's counting that first object, that first 0. Never forget your first 0. So list length can be helpful. It's saying, okay, how many items do you have in this list? How many pieces of data do you have? In this case, it's 10. If I change this data, maybe I keep adding stuff to it. So I'll put in a few extra numbers. You can see now it's up to 14. So it's not counting the values. It's just counting how many pieces of information there are. That's what list length is doing. All right, we're going to go down by 1, reverse list. So this component is also under sets. and then list, and then reverse list. It does exactly what you think it would do. We've got our numbers on the left-hand side here. We plug it into reverse list, and what do you know? Now those numbers are running in the opposite direction. So 1, which used to be at the top of our list, is now at the bottom. 5, which was second place, now is second from last, versus this value of 10, which used to be at the bottom and is now at the top. So it just takes all of those values and it flips the order, or it kind of reverses these index numbers, essentially. The values stay the same, the order is just flipped. Shift list is an interesting one. So shift list, again, this is just under sets list and then shift list. The little icon is kind of helpful for understanding what's happening here. It's taking your information and it's pushing those values by however much you specify. There's 2 inputs on the left-hand side here, list, which you're familiar with. Shift, that's how much you're kind of pushing those values along by. And then this one down at the bottom here, wrap, we've got a Boolean toggle plugged into that one. So this one is a little switch, a little true or false switch, and that determines whether or not something is true. So when it's set to false, you can see when I shift my list, so I'll change this number slider, you can see it's just kind of like pushing those values up. It's deleting the values at the top. So it's taking those values and it's shifting their position. So in this case, number 5, which used to have an index number of 1, gets shifted up to have the index number of 0. 2, which was at 2, now gets shifted up to have 1. So those index numbers are being shifted or pushed upward. And if I keep pushing them up, you can see the numbers start to dwindle and disappear. When I turn on wrap, so I turn the Boolean toggle for wrap onto true, you can see what it starts to do is instead of deleting those numbers, it just kind of pushes them back to the bottom. So if I start at 1, you can see that the index numbers have shifted. So number 5 is now top of the list. But that number 1 that used to be at the top, now she's brought back all the way down to the bottom. So instead of deleting it fully, it's kept that number, but it's just kind of shifted it or pushed it all the way down to the bottom. And so this way you kind of keep all your numbers, but you're just kind of pushing or shifting those values. So this is so painful. I'm so sorry. Shift list, that's what that is for. Sorting lists, this one's really helpful if you're trying to sort things like distance values or sort things by size. Sort list, it does exactly what you think it would do. You plug in your numbers here on the left-hand side. And then what it spits out on the right-hand side is those numbers in the correct or ascending order. So here on the left, we've got 1, 5, 2, 7, 8, 4, 3, 6. It takes all those numbers and it just rearranges them from smallest to largest. There's a second output on sort list. So it's got 2 inputs here, keys and values, and it's got 2 outputs, keys and values. And this is kind of interesting because you can take the keys or things that you're generally sorting by. So in this case, maybe we're sorting by these numbers here. We want to sort those by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can use that sorting operation to then sort kind of a separate list of objects. So we've got the numbers that are going from 1 to 10, but now we can take this list of text. Hi, secondary list. This is sorted using the first of an example that gets list order as guide. And then we shift and kind of reorder all of those text values in the same way that these numbers are being rearranged or reordered. So hi, this is an example of a secondary list that gets sorted using the first list's order as a guide. So that's what values is doing. So keys up at the top, this is what you're actually sorting, so the numbers in order. And then values, it's taking that same sorting order, so it's shuffling in the same way that it is these numbers, but you can plug whatever you want into here, and it'll sort them in the same way. Again, this might seem so stupid, but you just need to know that it exists, because it will come in handy later on. Replace items, this one's pretty Makes a fair amount of sense just by looking at it. We won't linger on it too long. I haven't used this one a ton in my Grasshopper life. But basically it's asking, okay, you've got your initial list of numbers. Maybe we want to stick a couple 99s in there to switch things up. The only other input you really need is where do you want to put those 99s? And in this case, it's asking for indices. So that's that index number on the left. So it's asking, okay, at what spots do you want to stick a 99? In this case, spot number 1, spot number 5, and spot number 8, which we can see if we go over to the output on the right-hand side. So spot number 1, spot number 5, and spot number 8 all end up with this new value 99 that we've plugged in. Not super critical. If that one doesn't make much sense, don't worry. It's not very useful. Split list is helpful. Again, we're just kind of going through all of the different ways that it's important to know and understand what an index number is doing. So split list, also under sets, list, and then split list. This one lets you just kind of take a list and split it into 2 chunks, given an index number. So you can see here when it's set to the number 6, it takes our list and everything up to the index number 6, everything that comes before that gets split into list A. So that comes into list A, and then everything after that goes into list B. Oops. So you can see where those values are coming from. 1, 5, 2, 7, 8, 4, that gets put into the list A. 3, 6, 9, 10, that gets put into list B. So split list makes sense. And then you can just kind of change that number slider around to control where that list is being split. There we go. That's kind of determining where that index is cutting it in half. Sublist, we're not really going to talk about that one. It's just kind of annoying, but you can take a look at it if you want. Again, I haven't really used it a ton. Ditto partition list. This is if you want to break a list into chunks of a certain dimension or size. So here we've got a list of numbers and then some numbers plugged into size. So that's asking how big do you want these chunks of information to be? In this case, 3 and then 2. So it takes this list, it chops it into length of 3. So 3 items, that goes into our first branch. And then 2 items, so the 7 and 8, that goes into our second branch. 3 items again, 4, 3, 6, that goes into our third branch. And then 9 and 10, and that's our last 2 numbers there. What's important to recognize here is that this is kind of one of the first times we're starting to see that number in the upper right-hand corner start to do some funky stuff. So instead of just being one number, usually a 0, you can see now there's a second 0, and there's also multiple bands that are showing up. So in a normal list of data, there's just kind of like 1 0 up at the top, and there's only one dark band up at the top. In this case, we've got some information that's starting to be split into chunks. So these darker bands start to identify different chunks of information. And these are what's known in Grasshopper as branches. So these are branches of information. So that's where we're going to come over to this data management over on the right-hand side here. And we're going to break into a little bit more detail what we're talking about when we talk about branches. I'm going to skip over this numeric sequences bit here. You can play around with that yourself. These are actually really helpful components to start to play with to generate lists of numbers, but just not super critical for what we're going to talk about right now. So I'll skip over this and maybe we can come back to it later if we've got some time. But for now, we're going to jump to this last column here that says data management. This is kind of the meat of what we're trying to get into today. And the setup is a little bit funky, but it's basically we're taking this grid here in the upper left-hand corner. It's got a bunch of kind of invisible connections. But we're going to take this grid and we're going to look at the data inside of this grid in a bunch of different ways. So you can see it's drawing that grid inside of RhinoSpace. You might see some crazy stuff starting to show up in Rhino. But underlying that crazy stuff is kind of a basic fundamental grid underneath. That's being drawn by our square grid component. I am just going to come over to this first little chunk over on the right-hand side. There's a little group here that's labeled unmodified. So in the upper left-hand corner, we've got a component called point. This is just a little container component that's holding all of the points that we're bringing over from Square Grid. So we can take a look at these points inside of Rhinospace by right-clicking and turning the preview on. You can see that suddenly you'll see kind of like this grid of green points at the intersection of my grid that I've created. And then the components that we have coming out of that, these are essentially just different ways of looking at the data that we've drawn here. So we've got our points, and then we've got 3 or 4 things coming out of those points that are just going to show us how that data is structured. First things first, I'm going to turn on this little preview here where it says point list. I'm going to right click and preview that one on. And you should see all of a sudden now those points have numbers that are starting to show up. They should have different colors. And hopefully you guys aren't seeing these little kind of floating point values, these little kind of like bubbles on top of them. Those are super annoying. Sorry. I'm not super sure why those are turned on. But what we really want to pay attention to is these points being turned into numbers here. So what's going on with this list of points? What do these numbers represent? If I grab a panel, so I'll double click and type in panel, and we take a look at what's coming out of this point component, you can see I've got a whole bunch of points. And those points are split into smaller chunks or branches, defined by these kind of darker bars. Within each one of these branches or darker bars here, these little chunks, this is a branch. We've got a list of points, so we've got our different point values here. And the index numbers on those run from 0 all the way up to 10. So what we're seeing when we look inside of Rhinospace and we see these numbers running from 0 to 10, those are the index numbers. So those are telling you kind of where in that list those points are. And this is super helpful for us because we can kind of take a look at these points in the grid. Look at the number that's being blown up really big. So in this case, maybe number 3 on the left-hand side here. And now we know that it's talking about number 3 in that list. So that's the index number. This point here, 030, that's talking about this point in space. And those numbers repeat. So you can see at this line all along the bottom, all of these values are 0, 0, 0, 0, 0, 0. And that's because all of these points along this farthest edge, they're all talking about the first item in this list. So they all have the index number 0. But they're just in different branches of our data tree. So if this is a branch up at the top, the first item in the list here is this point 0, 0, 0. If we come down to our second branch in the list, then the item at the top is 10, 0, 0. Again, these ways of describing points are talking about their location in 3D space. So the number on the left-hand side here, the first number in the list, oopsie, yikes. So this number in first place, that's talking about the X value. Second number is talking about the Y value, and third number is talking about the Z value. So when it says 10, 0, 0, that's talking about a point in space that is 10 units to the right in the x-axis and 0 units moved in the y or z axis. So this point here, point 0, is talking about this little purple 0 that we have in space. And so on and so forth. So for each branch of information, again, each one of these little chunks after a dark bar is a branch. Every single one of those has an item with index 0, and then a description of where that point is in space. So all of these zeros in RhinoSpace are just talking about the first point in every branch. And then from there, they all go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, those are the index numbers. So it's talking about where it is in space. Each one of these branches is something we can visualize in a slightly different way. So instead of looking at all of these numbers in one big fat boring list in a panel, we can also use a different component, this one just below point list. This one is called the parameter viewer, or param viewer. And it's under params, utilities, and then the icon is a little tree with a branch. And if you hover over it, it'll say a viewer for data structures. That's exactly what it does. If you drag it onto the canvas, it'll look something like this. It doesn't do anything if there's nothing plugged into it. If we plug our points into the param viewer, it gives you a little description of what's going on. So it says, okay, your data has 7 branches. These are the titles or names of the branches. 5, 6, 7 branches. And then over on the right, it tells me how many pieces of information we have in each branch. N just equals how many numbers or how many items there are. So N is just kind of the length of that list. So what we have going on here, we've got data with 7 branches. 1, 2, 3, 4, 5, 6, 7. That corresponds to what we're seeing in RhinoSpace here on the left-hand side. So we have the exact same thing. We've got branch 1 here, branch 2, branch 3, 4, 5, 6, and 7. So each of these kind of columns, if we're looking at them, each column is going to be a branch. And we can draw, there's kind of a different way of looking at this information that we can get to by double clicking on the param viewer. So if you double click on this one, it'll toggle between this kind of boring numeric view or numbers based way of looking at it versus this kind of more like interpretive dance style way of looking at your data. So if you double click, you can start to see your information structured in a slightly different way. This never made much sense to me, so if this is confusing to you, please just tune it out. It doesn't mean anything. It's like really not important. But each level of data is represented as kind of like a ring on a tree here. So you can see we've got data with 7 branches, data with 7 branches. All of those branches are represented on the right-hand side here. We've got branch number 1, 2, 3, 4, 5, 6, 7. And then these different rings, so the rings are talking about kind of like the inception layers of data inside your list. So you can see there's 1, 2, 3 rings of data. And these correspond to what these little numbers on the left-hand side are talking about. So this list of information here, each branch is labeled with kind of its relative position in those inception layers of data. So you can see there's 1, 2, 3 layers of information about that branch. That corresponds to what's going on here with 1, 2, 3 layers of information about that data. And these lines kind of indicate where that data starts to break apart. So in our first level of kind of inception about our data, our first kind of point all of that data is just kind of like structured together. Then we move up to the next level. It's still all in one piece. You can see it goes from kind of one dot of information to one dot of information. And then it's only on that kind of like third and final outer ring that things start to split into separate pieces. So 1, 2, 3, 4, 5, 6, 7. So it's moving from one solid chunk of information to 7 different branches. And we can kind of see how that's being drawn by turning on this little polyline component. So that's our kind of third way of looking at this piece of information or data. So we can grab or turn on this polyline component coming out of point. And if you preview that one on, what you should start to see in Rhino space is some lines being drawn vertically along those points. I'm just going to try turning off some stuff to see if we can get those points to go away. There we go. Sorry about that. So if I turn on my polyline and my point list, you can see it's drawing a straight line from 0 to 10. And if I turn off that original grid, you can see it's not drawing any horizontal lines. It's just drawing vertical lines from 0 to 10. And that's a function of the way that our data is structured. So if I look at a panel one more time, this is really the key point to understand here, is that when we take all these points and we plug them into the polyline component, that component only works within certain branches. So it says, okay, you want to draw a line between all of these vertices, but it only thinks about those vertices in little groups or chunks based on these branches. So since they're split into little groups, it's going to draw individual lines between each one of these points. So in our first branch here, we've got, beep boop. We've got these first list of points from 0 to 10. Again, that's just talking about this leftmost list of numbers from 0 all the way up to 10. So it's going to draw one line there through all of these points. Then it's going to come down to the next branch and draw a straight line through all of these points. So that's our second kind of purple list of numbers here. Same for the third branch. So it's going to draw a line through all those green numbers. Fourth branch, and so on. So basically, branches of data are like creating little groups. It keeps those points separate, and it prevents them from kind of interacting with each other. So all of these points are in separate little groups. The polyline component can only interact within those little groups. And so that's why we end up with separate lines for each column. I'm going to skip this simplified chunk here, and I'm going to move down to the one here where it says flattened. So this is something we came across really quickly last class. You'll remember last class there was just kind of a moment where we're like, don't worry about what this means, but right click on your points and flatten them. This is an operation of working with your data where instead of having separate branches, so separate little chunks or groups of information, when you hit flatten, it takes all of that information and squishes it onto one list or one branch. The points haven't changed at all, but the structure of the data of those points is completely different. So I'll come up to this first little box here and I'll just kind of preview off everything, that we've done before. So I'm going to turn off my point list and I'll turn off those polylines. So turn everything off. We don't want to see anything. I'll come down to flatten, and we can take a look at what's going on with these points here. So again, these points have just been through a really simple operation, which we can get to by right-clicking on any component and checking yes next to flatten. So right-click and then flatten. The icon has a little down arrow. And this kind of represents just like squishing all of your data into one branch. And you can see it's doing exactly that. So instead of numbers running from 0 to 10, and then 0 to 10, 0 to 10, 0 to 10, now you just have like a big fat list of numbers that goes from 0 all the way up to 76. And if we look at a panel, we look at what's coming out the other side, this starts to make sense. When we scroll down the panel, you can see there's no dark bars anymore. Everything's all on one branch. All of these points are in one big long list. The branch number in the upper right-hand corner, there's just one for everything. It's really simple. And everything's all in one big flattened branch. So the difference between the two, again, I'll just grab another panel so we can see side by side. Our original list of information. Oopsie, sorry. Before we made the kind of flatten operation, our info was split into little groups or chunks or branches. And now on the right-hand side, after we flattened everything, all of that data is on one big fat chunk. The branch number in the upper right-hand corner is much simpler. We've lost all of those kind of layers of separation. And this kind of gives us a little hint to what these numbers are talking about. So you'll remember our tree had kind of like 3 inception layers worth of data. And these layers kind of speak to different operations or ways of separating that data. And if we come down to look at what happens when we flatten that information, it kind of gives us a hint as to what's going on. So if we look at our branch number here, you can see there's 3 kind of numbers versus when we flatten it, it only goes down to 1 number. And this talks about those kind of inception rings of information. So the first one, this first number here, this first position, that's talking about kind of what column of information is your branch going to be. So first and foremost, this number here is asking, okay, what column are you in? The second point here is going to ask, okay, what row are you then in? And then the third is that position or that item in your list. So it's just these kind of like inception layers of information. And when you lose that information, everything is all on one big flattened list. You can see my index numbers now go all the way from 0 to 76. And that's reflected in how these points are being labeled in space. So they're not separate, they're all on one big flat list. And if we look at the param viewer now, so again, same deal, just a slightly different way of looking at data. You can see we have data with 1 branches. So there's only 1 branch. There's no kind of inception layers of memory of how those data were split into pieces. And then there's 77 items on that branch. So all of those pieces of information are on one list. The little tree viewer over on the right-hand side here, it just looks like a goofy line. And that's because there's no separation. There's no way of this data branching out into separate chunks. It's all just on one list. I'll scroll down a little bit further and we'll get to this other operation here. So this little group called grafted. I'll turn off my points list here and I'll turn on my points list for grafted. So in this case, we've kind of done the opposite of flatten. It's another operation we can do with our data to manipulate how it's broken into pieces. So we've done the really simple operation. Instead of choosing flatten, we've chosen this option here, which is called graft. This is like a tree metaphor. And so you can see now all of these points, their index number for all of them is 0. And that's because if we grab a panel and look at what's coming out the other side, every single point is on its own branch. So every single one gets its own little group. So therefore the index number for everything, its order in the list is always 0. It's always at the very beginning of a list because the branch only has kind of like one piece of information. And that's what Graph does. So instead of Flatten, which takes everything and squishes it down onto one list, Graph does the exact opposite. It takes everything and kind of splits it out into a branch of its own. And you can kind of get a better idea looking at this kind of wacky tree diagram here. So we have our first couple layers of information. So maybe the position in columns, position in rows, whatever. We get to the point where we have maybe a list of 10 points on each branch. So that's kind of where we started with. And then this next inception layer of data, this is represented by our graphed operation. So we've taken all of those points of information, and now each one gets its own branch. So every single piece of information gets its own branch on this crazy, insane tree. That's why we're seeing this wacky diagram show up. That's why all of these index numbers are 0. Every piece of information is on its own branch. If we try to draw a polyline between these points, it's going to give us a big fat error. So if we plug these points into a polyline component, it's not going to draw anything because every single piece of information is on its own branch. There's no points to connect to each other because there's no 2 points that are on the same branch of information. Nothing's going to connect. Nothing's going to be able to draw a line. They're all kind of isolated in their own branch. Versus if we come back up to where things were flattened, if I take a look at the polyline that comes out when we flattened all of our points, so I'll turn on polyline here, you can see what it's done is it's drawn a line between every single point on our list in order of the index numbers. So it starts at 0, it goes up to 10, and then it jumps down to 11, and then it goes up to 21, jumps down to 22, goes up to 32. So it follows the order of those index numbers. The order in which those points occur is really important for how the polyline is then being drawn. So everything's on one big flat list, but the order in which it came from is ultimately really important. So that's going on when we flatten or graphed stuff. We're either putting it on one big list or we're splitting it into smaller chunks. The reverse operation does exactly what it sounds like. So if we right click on our points and check this option here where it says reverse, if I turn on my points list, you can see it's taking our original point structure, so our very basic kind of list of columns here. And the only thing that's different, it has reversed the order of those points in our list. So instead of starting from 0 at the bottom here and then moving up to 10, it's taken the order of those index numbers and just flipped them. So now 0 starts at the top and works its way down to 10 at the bottom. The order of branches hasn't changed at all. It's just the index numbers inside each branch. So all items in each branch are reversed in order. Branch structure is left untouched. So if we look at this little branch diagram, it looks identical to what we started with, where we had all of these little branches here. The only thing that's different is just the order in which those points are drawn. So our initial 0 through 10 versus the flipped or reversed 10 through 0. That's what reverse is doing. If we come down one more to flip matrix, this one's kind of interesting and a little bit tricky to understand. So we've got this flip matrix component. This isn't like a quick operation we can do. It's an actual component that we have to stick on the canvas. And it's under sets, tree, and then flip matrix. The icon is like 2 Excel sheets. And that's because what we're doing here is we're swapping our rows and our columns of information. So this one's a little bit tricky to visualize, but if I turn on the points list, we should get a better idea of what's going on. So in our original orientation, we had 0, 0, 0, 0, 0, 0 running along the bottom, and then numbers were running from 0 to 10 along our columns. What flip matrix does is it takes those values and it swaps with their branch position. So all the highest branch paths are swapped for indexes. You can think of this as swapping rows and columns in a grid. So when we have a grid here, you can see the order of those points. Instead of running from 0 to 10 in the vertical direction, now they're running from 0 to 6 in the horizontal direction. So we've swapped. If I come back up to the beginning here and take a look at our initial panel, we've got these index numbers on the left-hand side. And we've got these branch numbers up at the top. We've taken those 2 numbers and we flipped them around. The values stay the same. So these points in space stay the exact same, but now instead their index number is flipped. So all of these points are gonna get a 0 as their index number. So it's gonna be 0, 0, 0, 0, 0, because it's coming from this branch up at the top. The ones in the next branch here are all gonna get 1, 1, 1, 1. And that's what we're seeing happen with the point numbers here. So 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, and so on and so forth. So that's what flip matrix is doing. It's taking those values and it's flipping the index with the branch number. The use cases for this will kind of become clear as we move through the course a little bit. I know it sounds awful right now, but it's helpful to have this as background information as to kind of like what's happening when we move forward and need to structure our data so that it pairs up nicely. And from here on out, I'm just going to show a quick little video that kind of explains the same topics in slightly different language. I found this to be super helpful and clear, and hopefully it'll kind of like make a little bit more sense to some of you. Helpful to have kind of an expert explain it versus me. It's this dude, Andrew Human. He's a real Grasshopper nerd, and he put this video together on data trees. We won't watch the whole thing. We're just going to watch the first little bit. But it's just a way of kind of describing the same thing in slightly different language that might be a little bit more helpful than me just kind of continuing to shout the word list at everyone. So we will take a look at this video. Hopefully the sound works okay. Let me just double check. Sound is going to come through. Let's try that. Okay. Maybe not Crestron audio. Crestron? All right. This guy's really cute. He's got a cute, like, high-pitched voice, and he's really sweet and good with data. So we're just going to watch this for a couple minutes, and then we'll wrap up for the day. I'm so sorry. We've made it through the hardest part. Hopefully, everything kind of comes together soon.
In this video, I'm going to explain Grasshopper data trees. This is not a beginner tutorial. It assumes you already have some understanding of basic Grasshopper concepts. There's content in here that will be useful to new learners of Grasshopper and some ideas that may even surprise experts. I want to share with you my very opinionated mental model of data trees. Not all Grasshopper users would agree with me about the best practices I recommend here, but I've been building up these ideas over more than a decade of personal and professional Grasshopper use, and I personally think they're a good way to think about how trees work. Some of the terms I'll use are official Grasshopper terminology, and some are just things I made up. So, without further ado, what's the deal with data trees? What are they? Data trees are how Grasshopper handles lists of lists. They're a record of the provenance of every single item. They're a vocabulary of operations you can use to transform the structure of the data, and a set of consistent rules for how components lace or match the data across multiple inputs to a component. So I'll explain each of these in turn. So in Grasshopper, data can be passed around from component to component in one of three forms: as a single item, a list, or a list of lists called the data tree. In a list, items have their own addresses called indices, which count from 0. So the fourth item in the list is at index 3. In a data tree, each list, called a branch of the tree, has its own more complex address called a branch path. One important thing to know is that data trees happen on their own. Grasshopper will automatically construct data trees for you. In fact, all data, even single items and lists, are just special cases of data trees. As I said at the beginning, they're a record of the provenance of every single item. To understand why this happens, you have to look closely at components. I'm going to introduce a made-up vocabulary for the kinds of components you encounter in Grasshopper so we can understand how they work with data trees. A component that takes in single items and produces single items, like extrude, is a one-to-one component. These components will not alter your data trees. The structure going in is the same as the structure coming out. If you feed this component a list will come out the other side. The index of each output item will match the index of the input it came from. A component like divide curve is what I call a one-to-many component. For every item you supply it, it will or can generate multiple items on the output. In order to keep your resulting data organized, these components append a new index to your branch path. This is useful when you supply a list of inputs. It keeps the resulting data organized by where it came from. So the index on the input gets appended to the branch path of the output. So if you look at the branch path, you can figure out which input item generated it. So this 2 at the end of the red branch path on the right comes from the index of the item from which it was generated, this sort of swoopy curve. A component like polyline is a many-to-one component. If you feed it a list, it will generate a single item on the output. It does not transform your branch paths. In the olden days of Grasshopper, before there were data trees, if you wanted to construct multiple polylines, you had to make multiple copies of the polyline component. And I still see beginner Grasshopper users making big copy-paste stacks of sets of components. With good mastery of data trees, you almost never need to do this. Instead, just structure your input into branches, and the component will treat each branch separately. So on the left, we've got 3 branches of 5 points each, and we pass these into polyline, and we now get 3 polylines out the other side. How do you know what kind of component you're dealing with? You hover over the inputs and outputs. If it doesn't say list or tree, you're dealing with item access. So this is an example of item access on the left and item access on the right. We call that a one-to-one. If you see as list on the left and no list on the right, you're dealing with a many-to-one component. And if you see list on the right, you're dealing with a one-to-many component. So a component like divide takes in a single item and generates a list of data on the output. Part of the reason why all this is important is because of what I call the hierarchy of geometry. In general, mastery of Grasshopper is all about learning a new way of thinking about modeling. In this way of thinking, you're always building up complex forms from simple ones, or deconstructing complex systems in order to operate on them in a more simple form. As you go down the hierarchy, you're often getting multiple items for every input item. So these are often one-to-many components. As you move back up, you are composing single items from multiple items. So you're usually dealing with many-to-one components. Let's walk through an example where we work our way down the hierarchy through a series of one-to-many components. So I've got a list with 2 BREPs. What happens when I want to get the faces from those BREPs using deconstruct BREP, which is a one-to-many component? It's going to organize the results by 2 new branches to tell me where each BREP face came from. The faces in branch 01 came from the BREP at index 1 in the original list. What if we want to get all the edges of each face with BREP edges, another component? It's going to create new branches, one for each face, with a list of edges in each one. The edges at branch 0, 1, 3 came from the face at index 3 on the BREP at index 1 in the original list. So this is what this looks like in Grasshopper. I've got my list of 2 BREPs with a branch path of just 0. I feed those into the deconstruct BREP component in order to get the faces back out. And because this is a one-to-many component, it generates 2 branches, 1 branch for each item I originally supplied it. And then I get a list of all of the faces belonging to each of my original BREPs. In turn, when I want to get the edges from each one of those faces, I feed it into BREP edges, and again, because this is one-to-many, it generates a new branch for every item that was input, and it does this by appending a new number to the end of the branch path, which corresponds to the index that was present in the previous list. So I know that a branch 001 is the second item in the previous list from the first item in the list even before that. So I also mentioned that data trees have a vocabulary of operations that you can use to transform the structure of the data. Let's take a look at a few of these. The most important operation is graft. Graft does the same thing that a one-to-many component does automatically. It puts every item on its own list. Every item is moved onto its own list, and what was previously its item index gets appended to the branch path. Now each item is at index 0 in its own new list. The opposite of a graft is called shift paths, or trim tree. There are 2 components in Grasshopper that perform basically the same operation. This operation takes a tree and chops off the last index of each branch path. Items that were previously on separate branches are grouped back together based on their new truncated branch paths. So items in branches that started with 01, like 010, 011, are now all back together in branch 01. The last operation is also the most destructive. If you want to discard your tree information entirely and condense the whole tree into a single list, you can flatten it. This is equivalent to doing trim tree for as many levels as are in your branches. So if you just trim tree all the way to the end, it's the equivalent of flattening. In order to really work with data trees, you need a mental model of how items from different inputs are matched to each other. So data trees consists of a set of rules for how components will match between multiple inputs to a component. So if you have a component that does a thing with some data going into input A and other data going into input B, how do you know which pieces from A and which pieces from B it will do that thing to? We're going to talk about this in the context of components with item access, but it will help you build a general intuition. So let's take a concatenate component, which just joins 2 things together. We're going to give it a list of length n. In this case, n equals 3, but I'm using n generically to refer to the length of a list that has more than 1 item. So we give it a list of length n into the first input, and a list with a single item into the second input. It will match that item to every item in the list, like so. So it's grabbed the items at index 0 in the first list and matched them up to the single item in the second list, and then the next one to the single item in the second list, and then the next one, and so on. If you have a list with n items in A and a list with n items in B, it's just going to go down the list, matching them item by item, and joining them on their index. So the items at index 0 will be processed together and joined. The items at index 1 will be processed together and joined, and the items at index 2 will be processed together and joined. So all of this is pretty simple and intuitive, and the good news is, if you understand this, you already understand branch matching behavior. And the reason for this is because branches get matched exactly the same way as items. It just happens twice. So when you're dealing with a complex set of data trees, and you're feeding one data tree into A and another data tree into B, it basically goes through this process 2 times. First, it matches the branches into pairs, and then it matches the items in each pair of branches. So let's walk through this example in a little more detail. So in this scenario, we have 2 branches in A and 1 branch in B. The branches in A have 3 items, and the branches in B also have 3 items. First, we match the branches. And since there are 2 branches in A but 1 in B, it reuses the single B branch across all the A branches. Then, it matches the items in each branch pair. This uses the same logic as the examples we saw earlier, matching each item by index.
Okay, I think I'm going to stop there. I'm so sorry. I think we'll put you out of your